a WikiVidi Documentaries production. Don't forget to like and subscribe. Enjoy. Classical conditioning. Classical conditioning refers to a learning procedure in which a biologically potent stimulus is paired with a previously neutral stimulus. It also refers to the learning process that results from this pairing, through which the neutral stimulus comes to elicit a response that is usually similar to the one elicited by the potent stimulus. These basic facts, which require many qualifications, were first studied in detail by Ivan Pavlov through experiments with dogs. Together with operant conditioning, classical conditioning became the foundation of behaviorism, a school of psychology which was dominant in the mid-20th century and is still an important influence on the practice of psychological therapy and the study of animal behavior. Classical conditioning is a basic learning process, and its neural substrates are now beginning to be understood. Definition: classical conditioning occurs when a conditioned stimulus is paired with an unconditioned stimulus. Usually, the conditioned stimulus is a neutral stimulus. The unconditioned stimulus is biologically potent, and the unconditioned response to the unconditioned stimulus is an unlearned reflex response. After pairing is repeated, the organism exhibits a conditioned response to the conditioned stimulus when the conditioned stimulus is presented alone. Thus, unlike the this is acquired through experience, and it is also less permanent than the Usually the conditioned response is similar to the unconditioned response, but sometimes it is quite different. For this and other reasons, most learning theorists suggest that the conditioned stimulus comes to signal or predict the unconditioned stimulus, and go on to analyze the consequences of this signal. Robert A. Rescorla provided a clear summary of this change in thinking, and its implications, in his 1988 article, Pavlovian Conditioning, It's Not What You Think It Is. Despite its widespread acceptance, Rescorla's thesis may not be defensible. Classical conditioning differs from operant or instrumental conditioning. In classical conditioning, behaviors are modified through the association of stimuli as described above, whereas in operant conditioning behaviors are modified by the effect they produce. Pavlov's research. The best-known and most thorough early work on classical conditioning was done by Ivan Pavlov, although Edwin Twitmeyer published some related findings a year earlier. During his research on the physiology of digestion in dogs, Pavlov developed a procedure that enabled him to study the digestive processes of animals over long periods of time. He redirected the animal's digestive fluids outside the body, where they could be measured. Pavlov noticed that his dogs began to salivate in the presence of the technician who normally fed them, rather than simply salivating in the presence of food. Pavlov called the dogs anticipatory salivation, psychic secretion. Putting these informal observations to an experimental test, Pavlov presented a stimulus, and then gave the dog food. After a few repetitions, the dogs started to salivate in response to the stimulus. Pavlov concluded that if a particular stimulus in the dog's surroundings was present when the dog was given food, then that stimulus could become associated with food and cause salivation on its own. Terminology. In Pavlov's experiments, the unconditioned stimulus was the dog food, because its effects did not depend on previous experience. The metronome's sound is originally a neutral stimulus, because it does not elicit salivation in the dogs. After conditioning, the metronome's sound becomes the conditioned stimulus, because its effects depend on its association with food. Likewise, the responses of the dog follow the same conditioned versus unconditioned arrangement. The conditioned response is the response to the conditioned stimulus, whereas the unconditioned response corresponds to the unconditioned stimulus. Pavlov reported many basic facts about conditioning. For example, he found that learning occurred most rapidly when the interval between the CS and the appearance of the US was relatively short. As noted earlier, it is often thought that the conditioned response is a replica of the unconditioned response. But Pavlov noted that saliva produced by the CS differs in composition from that produced by the US. In fact, this may be any new response to the previously neutral CS that can be clearly linked to experience with the conditional relationship of CS and US. It was also thought that repeated pairings are necessary for conditioning to emerge, but many SIS can be learned with a single trial, especially in fear conditioning and taste aversion learning. Forward conditioning. Learning is fastest in forward conditioning. During forward conditioning, the onset of the CS precedes the onset of the US in order to signal that the US will follow. Two common forms of forward conditioning are delay and trace conditioning. Simultaneous conditioning. During simultaneous conditioning, the CS and US are presented and terminated at the same time. For example, if a person hears a bell and has air puffed into their eye at the same time, and repeated pairings like this lead to the person blinking when they hear the bell despite the puff of air being absent, this demonstrates that simultaneous conditioning has occurred. Second-order and higher-order conditioning. Second-order or higher-order conditioning follow a two-step procedure. First, a neutral stimulus comes to signal a US through forward conditioning. Then a second neutral stimulus is paired with the first, and comes to yield its own conditioned response. For example, a bell might be paired with food until the bell elicits salivation. If a light is then paired with the bell, then the light may come to elicit salivation as well. The bell is the CS1 and the food is the US. The light becomes the CS2 once it is paired with the CS1. Backward conditioning. Backward conditioning occurs when a CS immediately follows a US. Unlike the usual conditioning procedure, in which the CS precedes the US, the conditioned response given to the CS tends to be inhibitory. This presumably happens because the CS serves as a signal that the US has ended, rather than as a signal that the US is about to appear. For example, a puff of air directed at a person's eye could be followed by the sound of a buzzer. Temporal conditioning. In temporal conditioning, a US is presented at regular intervals, for instance every 10 minutes. Conditioning is said to have occurred when this tends to occur shortly before each US. This suggests that animals have a biological clock that can serve as a CS. This method has also been used to study timing ability in animals. The example below shows the temporal conditioning, as US such as food to a hungry mouse is simply delivered on a regular time schedule such as every 30 seconds. After sufficient exposure, the mouse will begin to salivate just before the food delivery. This then makes it temporal conditioning, as it would appear that the mouse is conditioned to the passage of time. Zero contingency procedure. In this procedure, the CS is paired with the US, but the US also occurs at other times. If this occurs, it is predicted that the US is likely to happen in the absence of the CS. In other words, the CS does not predict the US. In this case, conditioning fails and the CS does not come to elicit a This finding that prediction rather than CS-US pairing is the key to conditioning greatly influenced subsequent conditioning research and theory. Extinction. In the extinction procedure, the CS is presented repeatedly in the absence of a US. This is done after a CS has been conditioned by one of the methods above. When this is done, this frequency eventually returns to pre-training levels. However, extinction does not completely eliminate the effects of the prior conditioning. This is demonstrated by spontaneous recovery when there is a sudden appearance of the after extinction occurs and other related phenomena. These phenomena can be explained by postulating accumulation of inhibition when a weak stimulus is presented. Acquisition. During acquisition, the CS and US are paired as described above. The extent of conditioning may be tracked by test trials. In these test trials, the CS is presented alone and the SR is measured. A single CS-US pairing may suffice to yield a SR on a test, but usually a number of pairings are necessary and there is a gradual increase in the conditioned response to the CS. This repeated number of trials increase the strength and/or frequency of the SR gradually. The speed of conditioning depends on a number of factors, such as the nature and strength of both the CS and the US, previous experience and the animal's motivational state. The process slows down as it nears completion. Extinction. If the CS is presented without the US, and this process is repeated continuously, the CS will eventually stop eliciting a SR. This means that the SR has been extinguished. This occurs due to a temporal sensitive relationship between the US and CS. The cessation or long temporal delay of CS-US pairing results in a learned decision to stop responding to a CS since there is a sufficient change in the rate at which the CS is being reinforced. Recovery from extinction. Several procedures lead to the recovery of a SR that had been first conditioned and then extinguished. This illustrates that the extinction procedure does not completely eliminate the effect of conditioning. These procedures are the following. Stimulus generalization. Stimulus generalization is said to occur if, after a particular CS has come to elicit a SR, another similar stimulus will elicit the same SR. Usually the more similar the CS and the test stimulus are, the stronger the SR to the test stimulus. The more the test stimulus differs from the CS, the weaker the SR will be, or the more it will differ from that previously observed. Stimulus discrimination. One observes stimulus discrimination when one stimulus elicits one SR and another stimulus elicits either another SR or no SR at all. This can be brought about by, for example, pairing CS1 with an effective US, and presenting CS2 with no US. Conditioned suppression. This is one of the most common ways to measure the strength of learning in classical conditioning. A typical example of this procedure is as follows. A rat first learns to press a lever through operant conditioning. Then, in a series of trials, the rat is exposed to a CS, a light or a noise, followed by the US, a mild electric shock. An association between the CS and US develops, and the rat slows or stops its lever pressing when the CS comes on. The rate of pressing during the CS measures the strength of classical conditioning. That is, the slower the rat presses, the stronger the association of the CS and the US. Phase 2. CS/US trials are continued, but these are interspersed with trials on which the CS is paired with a second CS, but not with the US. Typically, organisms show some CS/US trials, but stop responding on CS/CS- trials. Data sources. Experiments on theoretical issues in conditioning have mostly been done on vertebrates, especially rats and pigeons. However, conditioning has also been studied in invertebrates. And very important data on the neural basis of conditioning has come from experiments on the sea slug, Aplysia. Most relevant experiments have used the classical conditioning procedure, although instrumental conditioning experiments have also been used, and the strength of classical conditioning is often measured through its operant effects, as in conditioned suppression and auto-shaping. Stimulus-substitution theory. According to Pavlov, conditioning does not involve the acquisition of any new behavior, but rather the tendency to respond in old ways to new stimuli. Thus, he theorized that the CS merely substitutes for the US in evoking the reflex response. This explanation is called the stimulus-substitution theory of conditioning. A critical problem with the stimulus-substitution theory is that the SR are not always the same. Pavlov himself observed that a dog's saliva produced as a SR differed in composition from that produced as a UR. The SR is sometimes even the opposite of the UR. For example, the unconditional response to electric shock is an increase in heart rate, whereas the CS that has been paired with the electric shock elicits a decrease in heart rate. Rescaller-Wagner model. The Rescaller-Wagner model is a relatively simple yet powerful model of conditioning. The model predicts a number of important phenomena, but it also fails in important ways, thus leading to a number of modifications and alternative models. However, because much of the theoretical research on conditioning in the past 40 years has been instigated by this model or reactions to it, the RW model deserves a brief description here. The Rescaller-Wagner model argues that there is a limit to the amount of conditioning that can occur in the pairing of two stimuli. One determinant of this limit is the nature of the US. For example, pairing a bell with a juicy steak is more likely to produce salivation than pairing the bell with a piece of dry bread, and dry bread is likely to work better than a piece of cardboard. A key idea behind the RW model is that a CS signals or predicts the US. One might say that before conditioning, the subject is surprised by the US. However, after conditioning, the subject is no longer surprised, because the CS predicts the coming of the US. Here the workings of the model are illustrated with brief accounts of acquisition, extinction, and blocking. The model also predicts a number of other phenomena. See main article on the model. Brought to you by WikiVidi Documentaries. Would you like to know more?